So, first off, all the slides are available at this URL, and I'll give it again at the end. So, and one reason for giving that link is that some of the slides will have links to different resources and so on. But I thought I'd start with a little bit of history. And I remember, I don't know if Jose remembers this, but I think about 1977 there was a logo group meeting where Seymour talked. There's many ways to understand what logo is, but one way is this phrase that he used at that time. I never heard him say it another time, which was that it was child engineering of the best ideas in computer science. And at the time when logo was designed, and for a long time, the best ideas, and still many of the best ideas, come from the Lisp programming language, and that logo was directly inspired by all the ideas in Lisp and also some of the ideas going on in the AI community at the time. So I was inspired by that to try to come up with new programming languages that took into account some of the advances in computer science from the 60s. And the first one I did while I was at MIT, which was a system called Director that was trying to introduce some more object-oriented ideas into logo. Then I had one that was a visual programming language that relied only on the topology of the drawings, but that didn't work very well. So in 1992, I got the idea of ToonTalk, and I named it that because you're kind of programming the computer by using cartoons and tunes. So the 5 big ideas in it are listed right here. The first one is the idea is that you don't program by giving instructions, you program by demonstrating, kind of training the computer as to what you want. That's an old idea, but it's very challenging to get that to work in a general, flexible way, and I'll talk about how I do that. And then the other big idea was that computational abstractions could be turned into very concrete, kind of playful metaphors, and I'll show you the list in a minute. And again, this idea of taking the best ideas in computer science, well, at the time I was doing this, I thought the best ideas in computer science was coming from this subfield called concurrent constraint programming that had grown out of 3 different threads of computer science. One was concurrent programming, one was constraint programming, and logic programming. So, but again, if I'm going to child engineer this for children, we can't have any of that complexity with this. And one thing that's also unusual about this is that there's no difference between a program and its execution. You'll see what this means in a minute. And then the last idea was that rather than get ideas for the user interface from the usual graphical user interface places, I would look to computer games for ideas. And I also, in the design, was very much focused on children, but didn't want to kind of have a ceiling or a low ceiling. For people that know about Scratch and Snap, Scratch has a kind of pretty low ceiling in the sense there's only so much you can do with it, while Snap is a version of superset of Scratch that adds a lot more powerful ideas. Anyway, so that's where this came from. And so here's this list of when I said this idea of concretizations of abstractions. So as you'll see in ToonTalk, pieces of a program are represented by these robots, and the area, what a process is, or an object, or an actor, that's the backside of an object where robots are working with various kinds of elements. And then there's boxes, which are a very easy thing for even 4-year-olds to understand. You can put things in boxes, take things out of boxes, but those boxes end up playing the same role as vectors or arrays or messages and things. And there's these scales, you'll see them soon for comparing things. And then there's the basic atomic elements like numbers and text strings and so on. And then there's this really unusual aspect, which is the programming language builds upon this whole way in which different parts of the program can communicate with each other. And that's represented, as you'll see, by birds and their nest. And then the idea of birds and nest gets extended a bit to deal with events and functions. So I mentioned in 1992 I started working on ToonTalk. And by 96 I was doing a lot of testing in schools. And what I found was that I'd been kind of naive to think that all you needed was a good programming language and system. That worked for some of the children, but you really need a lot of surrounding resources, tutorials and puzzle games and help systems and so on. So I implemented these three, and I gave these stars because what surprised me was this puzzle game that I'll demonstrate really was very successful with the kids, and they really both enjoyed it and learned a lot about ToonTalk and about programming. And there was a lot of effort in some other things that worked, but not as well. So then a big European research project led by the Institute of Education in London started, called the Playground Project, which was, the goal was to help 4 to 8-year-olds make computer games, though even though that was, in reality they really only worked with 6, 7, 8-year-olds. And there was some new ideas that came out in the process of using ToonTalk in that project. One was something they called anima gadgets, which is a way to build a higher level component in ToonTalk and then share it and use it. And that's influenced a lot of my later work as well. And then the idea that ToonTalk happens inside of a city, but you could, researchers can make cities that are full of all sorts of things that are specific to a particular project. And then the other idea they had, or they needed, and I implemented and worked out, was the idea that the communication that usually goes on within a program could also work anywhere on the internet, that you could have communication happening across the internet. And that project was successful and led to a second project that was even bigger. And the first project was half on ToonTalk and half on a new version of Logo. This one was all around ToonTalk. And it was older children, but the idea was that the children would be not just building games, they often were building games, but the games had to have some science or mathematics as well, so they're building kind of serious games. And out of that project, and I'll show you soon what I mean by child engineered arithmetic, but that's something I'm kind of proud of. Another thing that was to take inspiration from the way in which Lego and IKEA have just a series of pictures to give instructions of how to do things without relying on text or explicit instructions. And then one of the partners connected up ToonTalk with one of the Mindstorms and did some interesting things. So one of the activities, threads in the Web Labs project was to deal with infinite sequences. So again, just remember that all the examples had to do with science and math, and I'll kind of give you examples more from the math part. There were ones where the kids were building linear programs or doing things in college and so on. So the first question that comes up is if you have 1/2, 1/4, 1/8 forever, what will it add up to? And if you, let me see if I, right. So, well, I could probably show you this one. No, this one. Here it is. So, so I'll explain later how how you should program such a thing. But this is a little program that's, if what it's doing is there's two programs running. One of them here keeps making numbers that are 1/2 of what it was before. And then this one receives these numbers and drops and adds them all up. So this is so what's happened is that the computer in some sense is being too fast here, because I wanted to show 1/2 and 1/4 and 1/8, but we've already gotten to a very big number. And one of the things is we could see this number as say a decimal, and it looks as if it's all nines. But if I took it out, we could. I don't know if you could see this. Oh, we got a.
Users can
Okay. Okay, great. We'll do that in a second. But we can see that we've gotten, you know, a very long number of nines, but at some point here, sorry, trying to make it bigger so you can see. Hopefully you could see that so we could keep running this, and we could see that it keeps getting closer and closer to 1. But if you were to do this, well, let me know. So here's the problem with the same thing if you were to explore this with another programming language. So here, if you look there, you'll see that it looks as if it's similar, you know, more and more nines. But what happens is that after 55 iterations, it's 1 forever, which is because almost all programming languages use floating point numbers that have a limited amount of accuracy. So this is just a simple version of it. JavaScript would be true in nearly every programming language. But at some point, you just would get exactly 1, which, if you're trying to use the computer to explore some mathematical question, that's kind of bad news. That it's giving you the wrong idea of arithmetic. What? It never converges, but well, it converges. You could say it converges at infinity. You could clearly, you could run it for years, and you get, you know, millions of decimal places and so on. But no. So that was what I was trying to show here, was that if I put this back here where it belongs and have it run some more. Let me refresh the page and see if that. And if we change it into a decimal number, it looks as if it's just going to try to get an extreme value here or something. Maybe that's enough. If we, you can see it's an awful lot of nines there, but actually, I think if we, it looks as if it's all the way nines, but one of the things I'll show you in a minute with the desktop version, well, even here, it turns out there's a way to make it bigger. I could just keep making the background bigger. Anyways. I'm just trying to see how far we can make this. Sometimes it just becomes awkward, just keep scrolling. Anyways, it does look as if it's all the way nice, but if we were to zoom in more and more. Oh, the other thing is, because it's the browser, I can zoom in. Well, anyways. I think it isn't, I don't think these are. Should I keep going? It's kind of, this is, I find that even some young kids get really fascinated by really big numbers or numbers that go on forever and stuff. But I could see some digits already here. Anyway. And, but one of the points of this example is, let me go back to the reason, is that like if we wanted to know what this denominator is, that I could just open up, so we've gotten this big. And if we let it run, it would be really bigger. So that's just the denominator. Oh, and if we wanted to look at the numerator, again, it's all sitting here, but it gets hard to see. We see that it's the same number except for one. And one thing that's fun is that you let this run for a while. And when I mentioned this idea of child engineering numbers, some of the ideas are that things, if they don't fit, they go smaller to the point where there's potentially any number of digits there, and make it bigger again. And then when you've got decimal numbers, they'll just go like this, and so that you have a way to always see numbers, and you could see it in different ways if we wanted to see it as a, again, as a fraction. All right, let's go back. And one idea here is that if you follow this link to the Wikipedia page, there's this whole kind of recreational math, but some of it becomes serious math about just exploring, the distributions of primes or, decimal expansions of various numbers and stuff, that you could just treat mathematics as some thing in which you do experiments on it, as well, of course, proving things or solving things. What? No. So the project, the part that I got involved in was on the math, but the one partner was doing things where the kids were learning about gravity and acceleration by building a little lunar lander game, and another group was making an ecology where animals were moving around and eating and starving and so on. And then there was, this was all done with at schools 11 to 14-year-olds. So that project ended 2005, and but the other thing that I did, which is probably too big a diversion right now, but I'm very proud of it because it was the most extreme project I think anybody's done, which is to explore cardinality of infinite sets in a very concrete way. So I could. I have this won't make much sense because it's going way too fast. But what's going on isn't very clear. So this is generating all the natural numbers, and one copy of it is ending up here, and then this guy is. This one is doubling every number that comes in, and this one's producing every other number. And then the results are being delivered there. So the point of this isn't to sort of show it as I'm showing it here. The way in which, the whole point is the kids would actually construct this and play with themselves, and they'd be, as they're doing it, they'd be running it. I'll show you later how you could run these things at a nice, slow, leisurely pace, and it isn't anywhere near as confusing. But the point is that here we should see all the even numbers produced one way, and here we're seeing all the even numbers produced another way. And I'm sorry it didn't start with 1 or 0. I just noticed it this morning. I left this demo in the state after demoing another time, and I didn't have the chance to reset it because I just didn't plan very well. But the point here is that this is the very first of 10 exercises where what normally you think of as a very abstract notion of infinite sets and how do you think about comparing them or something. This is the first puzzle they come up with faced with, which is that this process is producing all the natural numbers. This one's using every natural number to produce the evens because it's doubling. Oh, I'm sorry, I'm pointing at it. And then this one is the one that's just throws away every other number and produces the even numbers. So this uses every natural number to produce the evens. This one uses half of the natural numbers to produce the evens, and yet they produce the exact same thing. And it's kind of the first kind of puzzle. But they get all the way up to doing, first they introduce negative numbers and then rational numbers from 0 and 1, and then rational numbers. And what's really interesting about that one, even some really bright kids that really were very mathematically proficient, they got very thrown off by the fact that you could make some robot that would make all the rational numbers between 0 and 1. It would make a half and then a third and then 2/3 and then a fourth, and you had to do a little work to make sure it skipped 2/4 and then 3/4 and then 1/4. So they got that. And then another robot could take the output of that, all those rational numbers, and just take the reciprocal. And then they kind of convinced themselves that the reciprocal is going to be every rational number between 1 and infinity. And yet it's clearly the same size as the numbers from 0 to 1 because it's produced by just flipping them over, just doing the inverse. And we even get finally to Hilbert's Hotel and all this sort of stuff. But the big idea is that by having infinite processes and making very concrete, you could sort of think about infinity in a way that's easier to work with. And we even got work with 9 and 10-year-olds on this.
You cannot do that with
Right. Well, it'd be much more difficult and doesn't feel the same kind of concrete thing. But it'd be interesting to do that comparison sometime. But and this is clearly kind of more fun because you're seeing the things and doing. Right. So that was that project. And then Leonardo Magado at the UTAD, which I don't remember what it stands for, it's the university in Villarreal in Portugal. I was co-supervising him, and his thesis was about preschoolers and kindergarten children using Toontalk. And he looked at all of these different kinds of computer science concepts and sort of said, is there something that a 4-year-old could do in Toontalk that actually is related to these concepts? Obviously they're not learning it the same way that a high school or university student would, but they're still being exposed to an awful lot of computational ideas. So at this point, I'm going to hopefully be able to demonstrate Toontalk. I've had, we'll see in a second. What? Oh, no. No, I've been, well, how do I say this? So I was only working on ToonTalk pretty much exclusively for about 12, 13 years, from 1992 to about 2006. And there was a big long gap, and then about 2 years ago I came back to it, and that's coming up soon in the story. So in between there, I was mostly working with well, you know about the MyGen project at the Knowledge Lab, and then in Oxford with the agent-based modeling and the Modeling for All project that Fabio helped with. So, yeah.
So which language you are now developing?
So what I've been showing you so far, even though it's really later in the story, is the web-based version of ToonTalk. But what I'm starting right now to launch, hopefully it'll work, looking promising, is oh, it's good. Let's think, where is it? So this is the ToonTalk that was being used in all these projects. And it, as you'll see, it's a much more kind of playful thing. The idea is you're the programmer flying over this city, and you could enter a house. There's this help character that will talk to you if you push F1 or something. And then all the things you need to build programs are in this toolbox. And these are these concrete analogs of these computational abstractions. So, so I'm trying to think no, it's more than a tutorial. You're really doing the programming in this world. Like, I'll show you what often is like the second example that we do with kids or something. Is we put a number 1 in a box, and then we get a fresh robot, and then we give the robot the box, and then the robot will enter the robot's kind of imagination or thought bubble, and now we're training the robot, so the robot will remember what we are doing, and we could have him pick up the magic wand and copy a number and drop it on top. And then we say we're done. And then we could test this robot, and he'll remember what we did. And then when he's done, he looks at the box again and says, well, does it match what I'm thinking about? But he's only able to work with a box with a 1 in it. But we could make this a much more general program by erasing it. So now he'll work for any number. And he'll just repeatedly double this. We could make this, oh, I know it. Usually have this set up with it. Make it a little easier to see. And if we stand up, he'll keep doing it. And if we go outside, he's running as fast as he can. So now, this version I haven't touched for 10 years, and it used to be that it got very slow when you were working with big numbers, and you had to kind of explain to people why it was being slow. But it doesn't really matter anymore. So it's produced this number, and if we move it around, you can see it looks pretty big. But this is the thing that I want to reproduce in the web version, because the kids, you could take it outside, put it down on the grass, and see it better by making it taller or something. So then if I stand up, I should be able to see this number, and I could kind of go for a walk to see how big it is or something. And then if you get tired of walking, you could getting your helicopter. And it goes way out into the water. It's basically, you've made a number that's much bigger than the whole city or something, or the whole island. So there were so many times when kids that really weren't very interested in arithmetic or mathematics still got very excited when they made a number that was ridiculously big. And I remember one 10-year-old girl that really was always complaining about doing anything with arithmetic. She made a number and then worked out that how big it was, and then all of a sudden she ran off to all her friends and said, I made a number that's 2,423 digits long or something. So she was really proud of her big number. Anyways, but the point of this was to show you how sort of concrete and playful programming could be in this world. Oh, maybe I should just, before I leave it, let's go fly back to a house.
Do the kids enjoy the audience maneuvering?
Yeah. Yeah, so the world appeal, that's, I think, helped Lionel Morgado quite a lot, the fact that the kids could they enjoyed sort of the playfulness of the world. And I mentioned this thing about birds and nests, that you could take out a nest with an egg, and the bird hatches, and then if you give the bird something like your name or something, the bird will take it to the nest and cover it up. And, it's just sort of this kind of playful aspect. And what's surprising to people is that with just these few building blocks, you could build kind of computer science-y examples like, computing factorial or bank accounts or something. But you could also make games. So if I set this down and turn it on and then hide my hand, I could play Pong here, and if I let the ball get past me, and if I wanted to see how it worked, I could take the ball, for example, and copy it and set it down and flip it over. And we see it's got three sub-behaviors. These are what these kind of anima gadgets we call it. And if we take this out, we see it has these two robots here, one of them working on this box, and these are both for bouncing off of things, and then there's one for making a sound for colliding, another one for serving the ball again. And get rid of this first. Just clean it up a little bit. I have to. One of the things I kind of enjoyed was how sort of playful this environment could be. So one of the things I once had to give a demonstration to a school in Italy, and the kids didn't speak English. I didn't speak any Italian, but I was somehow having to demonstrate this to the kids. So, I at the point where I was showing the Pong game, the Pong doesn't seem very special. But when first off, I showed that, if I took, if I took this and let's see if I do this right. Might not have done it right. We'll see. Oh well. If I'd done it right, both balls would be bouncing around, and the game comes harder because you got two balls or something, right? The playground project actually had the ball have another behavior that if you just dropped it on the game, it would start moving in a random direction. You didn't have to kind of drop it specially to give it a speed, which I just didn't do. But what really impressed the kids was, and again, this was without any language, is I copied the paddle and copied the entire game. Sorry. Somehow I've got a different. Just want to set it down. So I'm going to make it smaller. Oh, now that I remember right, what I actually did, well, I'll show you this, and then I'll tell you what I really did with the kids, was this is the paddle behavior. And if I take the, oh no, did something there. I think I'll just have to tell you what I did, because something went funny with the way I made it. Oh, I think I know what happened. Sorry. What I wanted to show you was copying the game, and what I did accidentally was I just copied the background. There wasn't, so let me try again. There, we got to copy the game now. The point is, what I'm going to do is drop the paddle behavior on the game and flip the game back over. And actually, when I did it before, I used actually some of the balls I did it with instead of the paddle. But the point is that we now have this recursive version of Pong that we got. One of the paddles is a miniature version of the game, and I could have made the balls miniature versions, and could even have made done it, a couple times. Sorry about all that noise. The point is, everything is kind of first class. Everything could become given behaviors, and you could just take behaviors that are already there and use them in other contexts. Matter of fact, one of the things the project was quite proud of, the playground project, the first project, was when two 7-year-old boys, they saw two sample games that had been made. One was a Pong game, and one was a Space Invaders game. And they made Space Pong by first copying the invaders into Pong, but then they took just the behaviors for defending, for shooting the invaders, and added them to the paddle. So now you're playing Pong with the ball bouncing around, but you also have invaders that you have to shoot at the same time with the same. Anyways, they were very proud of their game. But the point was that by building all these things in this kind of modular. With what? Oh, with recursion. Recursion. Yeah, I think so. That this could be a playful way to introduce the idea of recursion or something. Yes. No, I agree.
But actually, you don't see what's happening inside the machine. How much is
No, you do in the sense that, here, let me show you. So, what did I just?
Because when you draw something inside, this is incorporated by the
No, but here I'll show you. I'm just going to go to another house because rather than cleaning that one up. By the way, I don't know why I still don't have why the mouse was working and it's not working, because it's much easier to use this with a mouse.
Everything happens inside of the house.
Yes, that's but in the web version I kind of backed off on that. But here, let's. I'll just make a copy of the paddle. suppose you want to understand better how the paddle works. I could take the paddle, flip it over, and in this case it's pretty simple. There's just this one robot, and we could actually watch what he's doing, but what I want to do is flip this back over. Strange things are happening. So it's being, oh, there it goes. Okay, things are working. So what's happening is there's this thing here which is just measuring how much the mouse speed. So if I move it down, it's negative. Move it up, it's positive. And then this robot is copying whatever the speed is over to the speed for the paddle. So the paddle has kind of probably gone way up to the top of the room here, but if I start moving downward, we'll start to get a negative velocity or something. Now it's got a negative speed, we'll see. So it's a bit confusing to watch some real-time program like this super slowed down, but you should be able to get a sense of how this one robot is making the paddle follow the mouse's vertical positioning. And any of these behaviors, you can just pull out the robots and watch them on their own, seeing how they work. So there's a sense in which you can.
Who is doing the testing there? How do you know when the robot is doing the test?
Right. Oh yes. So for some of the game things, you did need a sensor. Well, maybe I'll show you this because it's interesting. If we just go. So if you take any artwork, it could be this kind of built-in one or something you brought in. When you flip it over, this notebook comes out, and it's got all sorts of sensors. Like this one is sensing how far it is from to the right of the left edge. But it's also not just a sensor. But if I drop something on it, it'll actually change the position of the ball or the background or something. Right? Here, I'll show you again. So the sensors are typically two-way like this. Now, besides, left and right and speed and the width and the height, there's this one that's showing whether it's colliding with anything. And it's missing right now, and if I go over here, we see it's colliding or something. And I go back here. So this is the sensor that you can match against, whether it's in one of those two states, and a robot could do something. So whether it's sensing this colliding or not is kind of opaque. It's built in as a primitive, but then it's something that you could then use to make the ball bounce or do whatever.
It's already part of the ball.
Yeah, it's part of what it means to be a picture, is that it's associated with all of these kinds of sensors. Right.
So you have two balls for particular context, or for games and everything else, or the general ball?
Yeah. So this is completely just general programming, and then the question is, what do you kind of get in the notebook? And the notebook is kind of corresponds with sort of the metaphor of the file system. So here, I think this is worth showing. What the Playground project did, and Web Labs did something like this too, was they custom made a city. This is the playground here. This is the playground city. So they took ToonTalk, but within ToonTalk they customized it and saved it. And for some reason, it's not playground. No, it is. So, so they put in whatever it is, thousands of objects into this city. And over here they have all sorts of resources for making games. Over here they've got some sample games, an adventure game, action games, number games. And then over here they've got various kinds of behaviors that you could use for making things appear or disappear, changing pictures, making sounds, and so on. And if we, what they also did was not just, they also changed what was in the notebook in some sense, so that there's different shapes here, there's different sounds, there's all these games they put in here, various kinds of gadgets and stuff, so that, remember that, so the system is kind of everything in the sense that's in this toolbox and the couple tools that go with it. While the notebook is like what file system you have, and they created one with special, and maybe it's while we're here, I'll show you what Ananima Gadget's all about. So if we grab this, just to sort of get a fresh copy, and I turn it on, it sort of demonstrates that there's two different ways things are disappearing here. They're either blowing up or not. But if we wanted that behavior, what we could do is copy this bomb, which again we could use these behaviors for any kind of picture. Let's flip it over. So here's the behaviors for going right and for exploding when you hit something, and you could take those and use them in your own program, or but these are things that anybody can make. I mean, these happen to be made by the researchers. But the idea was that they're behaviors that you can sort of see in isolation, and then pull them out and combine them, use them in your games, so that you didn't always have to do bottom-up programming, you could do middle-up programming. So maybe I should go on. Yeah. Oh yes, yeah. That's yeah. As a matter of fact, right. Yeah, no, that's a very good question. So that's kind of what I was saying that I discovered 3 or 4 years into the project, which is, by the way, Microsoft used to make this, I think, have this square around it. It was just,
To play a game of learn how to use groups on click here.
So this is one way in which some kids can learn, which just started off listening to what Petey here has to say.
Click here to see what demos you can watch.
And go on. So let. What? No. So also, yeah. Well, so here, let me get rid of them.
Click me again when I'm leaving.
So, a lot of kids learned a lot from the puzzle game. So let me show you that. So first off, there's a little bit of a background story you'll see in a second, which is that, let's see, here we go. So the island was a great place, but then disaster struck and it's sinking. And Marty the Martian comes in to rescue everybody with his spaceship, but then his spaceship crashes. So you volunteered to parachute down to help him fix his spaceship or something. So here you are, and this time all that's left on the island is the crashed rocket and the one house. And you go in.
You must be in the commander I want. Oh, am I glad to see you. Thanks for coming to help me fix the ship. Okay, first we'll need to fix the ship's computer. It'll need numbers to work. Can you please go into the house next door and return with the box we're going to use it? If you ever have any problems, come back over here and I'll try to help you.
So, the idea of the puzzles is that you're in a very constrained situation here. You don't have all the objects. And kids very quickly figure you could pick things up and drop them. So here you're just learning very basic things about boxes, and then you need to put it in your pocket to give it back to Marty or something.
Okay, now we'll move forward.
So, again, because there's not much else you could do here, you kids eventually, will drop one on another and get it smashed together. Now, the puzzles go on, there's like 50 in the series, but even by puzzle 12 or 13, you're actually training robots to make the numbers that only need, and then to make text things that you need, and other stuff. So it's a way to incrementally introduce new programming elements, but also some programming techniques. But the important thing is that the kids could discover them because they're in such a constrained world that only a subset of the kind of objects that you could possibly need. And if you got stuck, which of course some kids did, every time you went back to Marty empty-handed or with the wrong thing, he'd get a little thing to, what to do. Oh, to be creative on their own? Yeah, so in both of the research projects, they had a lot of activity sheets that would kind of guide them in various ways. And sometimes the activity sheets, like I mentioned, were inspired by Lego pictorial instructions or IKEA pictorial instructions. They were given ideas of what to build, but they were... What I've seen with Lego as well, when most kids buy a brand new Lego set, and it's got these instructions, they'll carefully build exactly what's on the box. But then once they've done that once or twice, then they start being creative and making variants or taking two sets and combining them or something. So many of the kids were doing that here as well. But they would start off being given pretty detailed guidance, and then when you get familiar enough that they start to become more creative and exploratory. I mean, a lot of them are... Yeah. It really varied an awful lot. So one more thing they got, which was it was these demos aren't just videos or something. So like the introductory tour is kind of what I was doing a bit myself, but then there's silly ones like how to build a town of exploding houses and other stuff. But there's some computer sciencey examples. But then here's one where it's supposed to show you how two kids are building the Fawn game from scratch. And one of the things I purposely did too was...
Hi, Mickey. I think I can build a ping pong game in Toon Talk. Want to help?
Hi, Sally. I don't know. I'm just a beginner. I haven't done much besides an introductory talk. I don't think I'll be much help.
What,
You'll pick it up fast. Come on.
this looks like a
it's
video,
fun.
but
Well, all right.
Great. You want it, huh?
I thought we were going to play with Toon Talk. Besides, I'm just a kid.
No. I mean, you sit in front of the computer and use the keyboard and mouse.
Okay. And you'll tell me what to do?
We'll work things out together. Okay, let's land and go in a house.
Which one?
Doesn't matter, you choose.
so this ends up being a thing in 3 acts or something.
How do you sit?
Just like anyone else. What do you mean?
I mean in Toon Talk.
Oh, just push in and out.
Okay,
And-
now what?
Let's see. We'll start with the tab.
Watch this. I just hit any keyboard, and now you get these like VCR-like controls. But if I push this, no, that's it. By the way, the desktop version, yeah, that's what I thought. At any point, it becomes live. Is the point. This isn't like a video. At any point, I could interrupt it, and now I'm in that exact state, and I could fiddle around and explore that world that they were in the middle of at that point. And then there's ways to get back to the video and so on. But so that's another kind of way in which they could learn both the language and some programming techniques. But I think there's still a little bit more I wanted to show. Does it matter how much time we're using? Is it an issue? Okay, good. All right, so that was the desktop version, and it only runs in Windows and hasn't been worked on for many years. So then, 2 years ago, I got the idea of starting again with Toon Talk, but the idea is that instead of being a Windows application or something like this would just be what people call a web app now, just something that runs in the browser. And the first question was, who would I build it for? So one thing is that it's another way to understand computational thinking in computer science. And one of the slogans that I keep promoting is this one that Marvin Minsky used to say all the time, which is, if you understand something in only one way, then you don't really understand it at all. So Toon Talk provides a very different way to understand computation than Logo does or Scratch does or something. And having a few different ways of understanding something provides a much deeper, better understanding. So the fact that it's different kind of justifies why you need yet another one, because these days there's gotten to be hundreds of programming languages for children. So another thing is, and I'll demonstrate this, which is that for anyone, children included, that want to make a web page in which there's some interactive cool stuff on it, this could be the tool for doing it. But rather than having to learn JavaScript or something, giving behaviors to any web element by putting robots in it. And then we saw the Pawn game. I mentioned the Space Invaders, and so it could be a tool for making computer games. And I mentioned that much of my efforts in the last 10 years at Oxford have been around agent-based modeling and things like that. Logo that I'm trying to work out a way in which you could do some of those things in Toon Talk as well. And one of the things that was a real pleasure to see with E&L's was how these 4 or 5-year-olds that couldn't read yet could still do quite a lot with Toontalk, because you saw how everything was, just concrete playful elements. You didn't need to be able to read. And I haven't really gotten as far with the web version as I have with the desktop version. And then it was important that this isn't, even though it's a web, we could call it a web app, it's really a browser app in the sense that if the files are on your local system, it works just as well, and that you don't need an internet connection, especially given the fact that most of the children in the world don't have internet connections, in the developing world especially. And then I really wanted to do this in such a way that the open source community could contribute. So far, I haven't implemented any of the city aspects in the web version. So the web version, you start off when you're on the floor, and you're always on the floor. You can't sit down. You can't move around yet. But on the other hand, all sorts of browser things are available inside of Toontalk, and I'll show that soon. That any kind of browser element, download, just fits right in. And it's also true of the style sheets and the kind of events that happen within the browser, mouse events, keyboard events, and touch events. And the desktop version had a very simple metaphor, which was that on the back of something, there could be the robots working that give that thing its behavior. So you normally would, if you're just using it directly, you just see it doing things, but if you flip it over, you could see it. And that metaphor really worked very well, but the problem was that sometimes you want to see both at the same time. You want to see the front end of that. So I decided to do that, even though because it's so useful, but it's not clear that it just seems like a funny metaphor to say that here's the front of the thing, here's the back of the thing, and you're seeing both at the same time. In the desktop version, for simplicity, you could only have robots working on a box. But of course, if you put anything in a box, you could even put boxes inside of boxes, but you could put birds and robots, all sorts of things in boxes. So the robots could still work on any kind of element. But I wanted to make it much more general here, that the robots could be working directly on an element or the Toontalk widget. And then I even went the next step, which is if a robot can be working on anything, why can't a robot work on another robot? So robots can train robots in the web version. So, time to do a demo. It's just,
The report is written by the
the which part of this stuff?
the fact that it went back to the kickoff is written by the educational thinking movement.
That was part of it, but I think it was just always,
Because this is happening in general with all computer programming, right? People have forgotten that.
Yeah, no, it's true that it's become a very popular and hot topic, and everybody's doing something with, even you go to code.org and they say, 150 million people have done an hour of programming, and then they've got videos of movie stars and rock music stars and Obama doing a 1 hour and talking to kids. So everybody's doing it. That is one of the motivations, but I wouldn't say it's even the biggest one. I think it's really just going back to the original motivation. Here's a story I once heard about after the logo group became part of the media lab or something, which is that the graduate students of Seymour Papert started to realize that there were two different subgroups. There was the powerful ideas, which is really a superset of computational thinking, and it's sort of how computing could help kids learn new ways of thinking and become better thinkers and problem solvers. And the other group was how computers could empower children to be so creative, to make things they can never make before. They can make games and animations and interactive art exhibition and music and stuff. And that, of course there's a lot of overlap, and that always was sort of both goals, I think, of Seymour as well. The powerful ideas and enabling children to be very creative and creative in a way that was never possible before, because anything they could imagine, well, in principle, anything you could imagine could then be kind of built or explored via programming. I think both Seymour and Alan Kay talked about the protean nature of programming or something, in the sense that you could shape it into making it be an art thing or a music thing or a game thing or a math thing. It's just...
Actually, he started with this, the 25
Oh yeah, 20 I think it was, but yeah, right. Yes. But even then, I think with some of the examples ones it was, maybe it wasn't as connected to powerful ideas and like that. But
I think the powerful ideas came later, right?
Yeah.
Came with the first part.
Yeah, though there's, I think it was a few years earlier, but yeah. So, let me show you. Just clean up this word. So, again, this is a little bit like being on the floor in the opening, and we've got many of the same kinds of building blocks here, and let me just think that's a good thing to demonstrate or something. Well, first I'll just show you that exact same program we did in or variant of the one. So remember in the desktop one when I was doubling the number, I had to put the number in a box and give it to the robot and so on. But here the metaphor is a bit different. You open up the back side, and then you put a robot on the back to work on this. And then he could do various things. So suppose, I'm just going to try and come up with a little different, just have him pick up a 1. Instead of doubling it, he's going to triple it or something. So he's going to change this to a 3 and choose the operation for multiplication. And then he'll drop this on the number he's working. And I'll say stop training. And like before, he'll only work on the number he's trained on, so we won't erase this or something. So now if I run this, the robot, somehow I introduced the recently with this bug where the robots start working, they're a bit slow like this. Anyways, so he'll do what he was trained to do, pick up a 1, change it to a 3, and then change it to a multiply, and then drop it on the number he's working on.
So everything you did,
yeah, and he just does it over again. And so one thing we could do is stop until I notice. Good. So the robot. Oh, the other thing is all of these have this little advanced feature, so that the simplest things are just available right away. But if you click on that, you could see we could you know, whether he runs once or repeatedly is a checkbox. We could say we want him to run very fast. We could say that I'm a robot who triples a number, and give him a name like Trip. And there's even more fancy things we could do. I'll come back to that or something. So, so now if I'm running, we should kind of, you know, much more quickly do this. But like all robots, if we stop watching them, it's not supposed to do that. Anyway, they'll just keep, you know, working as fast as you can or something. So, stop. One thing too that paid some attention to is it's not great generated text, but it's at least one way of understanding what a robot does. He triples a number when working on something that matches a number. He'll pick up a 1, drop it on the back side, open the back side, edit the number by changing it to 3, the numerator to 3. So it has the full details of what this robot is doing. Since I stopped him right in the middle, he was in the middle and left this here. Don't really want that. So one thing that's nice about the web is that there's all of these libraries that you can connect to. And one of them is a Google Drive. So if I click on this settings thing, that I didn't give a name to this. I should, let me start over here. So it'll make it should make a copy of, so it made a copy of this current state and calls it the Unicamp demo. And because I'm always logged into Google, it put it actually in my Google, because I gave permission to ToonTalk to do this, it put this program in my Google Drive. And because it's in Google Drive, I could, just like anything in Google Drive, I could say, share it with anybody with, list the people, or I could say share it with anybody that has this URL, or I could say share it with the world, and then it becomes something that anybody should be able to access and to bring into their ToonTalk. But then there's this additional idea, which is this idea of having a published page. So if I say right now I want to publish my program, I just click publish, and it says creating your web page, and then it added this link here, and now I go to this. And this is also being hosted on Google, but what's different here is that this is a public page that's a web page, and I could say here, click to watch this triple. Whatever. And I could say, click again. So, maybe just to prove the point, if I took this URL and I started, Internet Explorer or something, where I'm not logged into Google Drive or something. So this would be as if I sent the URL to somebody, or embedded it in a web page or something. Then I don't want to edit this. So I guess somehow it's giving me the option to log in, which I don't really want. But anyway, the point is, when I was in the other, here, I could, say I want to make this bold and I want to make this red or whatever. All the usual kind of things, and there's more kinds of changes I can make to it. While I only, when I shared the URL with this other person, who's in this case Internet Explorer, it's no longer editable. But if I, if it's, as it says, if I click on it, we see very quickly it's trickling away or something. And
People, like Japanese Spanish,
no,
they have a community set up there.
no. As a matter of fact, I'll show you. I'll jump ahead to the very last slide, because we're getting close to the end anyways. But the very last slide says, anybody wants to contribute, it's an open source project. It's all on GitHub.
How are kids using it?
Yeah, no. So I haven't. Well, you're jumping ahead. The problem, there's a list of all the things it doesn't quite yet do, and so I haven't really been doing much user testing, because I know there's all sorts of things missing, and there's things that are a bit broken and so on. Right? So hopefully that's going to happen in a few months. That it will be kind of pretty complete.
Because when you need to do your project to compare who is using Drupal and who is using something else, and see how much they're getting in the education material.
Yeah.
But this is very different because of program.
Yes, that's very different, and that's, I think, what makes me feel like the world needs something like this, because if you go look around these days, there must be dozens and dozens of variants of Scratch. There's Tinker, there's Snap, there's Blockly, and even things like the MIT App Inventor is really much like Scratch, except it's got some different primitives. And
In your course here, we use processing.
yeah, we should talk about processing. I never got excited about it, but I know that the artists,
Yeah.
media people have really been excited about it. Yeah.
These guys use it, so we use processing to students.
Right. Let me see what I wanted to show you here. I want to, here's something. So, let's see if this works. It may not. I'm being a little bit brave here, but if I took this picture and come over here, sorry. I don't know what's going to happen. I don't think anything's going to happen. I forgot that I left this in this. Oh, it worked anyways. Okay, good. So let's get rid of that. So this, first off, notice that all I had to do was drag it from another web page and drop it, and here it is. And now when I click on it, we get sensors very much like we saw before, so that if I trained a robot to, let's make it wider or something, and stop training, then when I ask this robot to run, he'll just keep dropping one on the width. And the problem with this particular demo is that he could run too fast. We'll see this in a second. Whoops, you see what happened? Very quickly, this became ridiculously wide or something. So one way to deal with that also shows off some new ideas. Where did the robot go? Oh, there it is. I'm going to show you, you don't have to sort of have constants built into your program. So what we could do is we could put some speed in which you want something to change, say like 100th or something. And then for convenience, we'll check a box that says copy it whenever it's dragged. So now there's an infinite stack of 100s here. And also I'm going to set this back to something more reasonable. Oh, I see. It's also way off the screen because there it is. Okay. Now we don't have to be limited to just these built-in sensors. The idea is that actually any CSS property could be made available in the advanced things. So here we see the geometric ones, but I could pick over here a rotation or something. And maybe I don't really want to ever have robots deal with the left and right, so we could simplify the thing and just have it. Right. So now if we see that this picture now has just 3, and we could have different speeds for each one, but what I'm going to do is train a robot that will drop this on each one of these. And then if I close this and close this, oh no, where'd it go? There. Anyway, so it's rotating and getting bigger and bigger. And just like the Anima gadgets we saw before, that if we wanted to use the same thing for this image, to drop this here, and then I take the back of this, and it's a good idea to make it smaller. Oops. I'm much better with a mouse than I don't know what I just did. It's surrender something. So I put it down. One thing sometimes, just hitting refresh helps, because everything is being stored not just in the Google Drive anymore. Well, maybe I don't know where. Well, somehow I think what I did was I made this thing into. Oh, there it is. There's something. What I should have done was made it so that you can't make it this narrow. Because I said that I wanted to, oh well, I'll just drop it here. It would normally be a nice smaller version, but I accidentally made it very thin. But it should be the case that if I run this now, we should see it working on this new image. And one of the reasons I haven't tried this with kids is there are these little glitches. Like you see that somehow these have gotten stuck together, and I can't really just refresh and see if it fixes the problem. I wanted to close this. Doing it. Because there's the stop, there's the information, there's the go button. Anyways, you can just believe me that if we could get rid of this, this would also spin and grow at a higher speed. And the only reason it isn't is because I can't hit the close button because it's buried underneath this other button. But notice nice little help here that even is using a miniature of the picture and saying, you're pointing what you're doing. So one more thing to explain is that, well, I'll just say it rather than show you, which is that you could get birds that will deliver messages that correspond to any DOM events, like a mouse click or a keyboard event or whatever. Well, here's the simplest one I'll just show you right now. Without doing anything, this one will just, by default, every time I type a key, it just ends up on this nest, and a robot could be picking up these letters and doing something with it. But it could also be for mouse clicks or other kinds of things. So one thing that I think is also very interesting about being web-based is here's the manual, which is saying, this is workspaces, here's numbers, how birds and nests work or something. And if I click on this, it'll start to explain how numbers work and how you could add them. But it just says right here in the manual, just pick up a number, in this case a Google, and drop it on a 1, and how you can make it wider and do it again or something. So right there in the manual, everything is live. You can just embed any kind of ToonTalk element right there in the manual itself. Here you could just click and see, what is this as a decimal number or whatever. So that's and that's true of the manual, but it also could be true of anything that you're, if I was wanting to explain more about, I don't know, sequences of numbers or something, then I can make a page that has live ToonTalk elements that explain it, or about what it means to rotate a picture or something. All those things could be just made available or something. What's interesting about the tour is this is something anybody could train. I just trained 2 robots. This one will start working and he'll be using another robot. And what the robot does is he first off takes a sound element and starts it running, where I'm just narrating what's happening. And I got the volume kind of low, but that's probably good because I want to talk over it. So I'm just going through saying, here's how you could add numbers, here's how you could do it over and over again. So here's where a robot will train a robot. So this robot has picked up a robot, and as he's doing things, the little robot is following him around. So these are very straightforward to make, especially when I'm about the narration. And what they're relying on is robots can be trained to train robots, and also that you could ask the robot to run at the original speed that it was recorded at. So normally they run at what's called normal speed, which is one that's kind of clearest as what it's doing. But you could have it run exactly at the speed that it was used when you trained it. And this guy's going on and doing it again. But even while he's running, this is all live. If I wanted to, add this, or if I wanted to see what's this really doing again, I could. Well, maybe I have to do. Well, I could do it. The reason I can't click on this is because it's running, and if I stop it, then I can ruin the demo. But anyways, it's all live, even though it's a demo. Is the point, and I could export things or something. Yeah. Yes. Yeah. Right. Yes. So that's another sense in which it's not really ready for wide scale use, because I think if I search for the word turtle, there it is. So here's a sample program where I did build something kind of familiar and useful. It might not have been turned on. So if I if I ask this turtle to go forward 50, goes forward 50, and if I say go turn right, and if I want him to go forward only 5 or something like that. But the point isn't that, the point is that then you could make, oh, I just did. See, there's all these bugs. Oh, I wanted to drop it on the turtle, the bird, right? Not the turtle. Anyways, but if we wanted to see how this guy is really working, we could look at the turtle and see there's this robot that's implements forward, which is really a really long, complicated robot. It turns out not an easy thing to do forward. And then he's got behind him another robot that says, well, if forward isn't going to handle this, let this other robot try it, and this is the one that deals with turning right and so on. And, so the point is that if I wanted to use this turtle in my program, and I just went to this website, this page, so well, just fix it this way. This idea of having these pages as sort of sub-pages has many advantages, but it makes it more difficult. Or maybe I could drag this and drop it through anyway. I might have succeeded. Yeah, even though it came up. But anyways, now I have them here, and I have somewhere else a little demo where you're making them go in a circle like this, with, a robot repeatedly giving them a forward one, a right one, or something, just to prove that it could be done. And forget it. Let me see. If I yes, so the point is that you very much possible to make web pages that have all these things that somebody can just drag into their world and use them and see how they work. And it could be so there was another little example one that I put somewhere, which was just a little widget that enabled you to jump to another web page. So you could basically have a URL on the back and specify the conditions under which it would jump to another URL, and then I use it. I'm starting to make the puzzle game here. So if this is very much without the kind of fun story behind it and Marty and all this, if I just pick this up and drop it here, well, it goes now to the next puzzle and so on. But if I wanted to see how this works, I kind of made it, because it's supposed to be that you're not supposed to cheat here and just open this up, but there's a, I forget if it's Alt click or something. No, Control click. Oh, there we go. Anyways, so here we can finally open it up and see that there's this robot that will, when the scale receives, when this nest receives a 4, the scale will tilt even, and then the robot is waiting for the scale to be even, and then it'll go ahead and use that other widget to say, go to now to puzzle 3 or something. The point is that everything can be kind of built in the system, but it's still kind of awkward. So I think we've got a slide or two more. Right. So I think of the kernel of the language as being essentially done, and the manual is in good shape. Well, there's only one of these video tours, and really a whole bunch to show different aspects and features. I've used it on tablets and phones, and it's pretty awkward, but at least I got it so it's possible, but it's not. It needs more work to be really more nice enough. The library is exactly what I'm asking about, is the library of all sorts of useful programs that you could just use and change and combine, and then sample programs to show, all this kinds of stuff you could do, which the desktop version has a rather rich one, and even richer if you include the stuff constructed in the playground and web apps.
Are you the only one who works on it?
Yeah, that's the problem, and I'm only doing it part-time. Yeah. This isn't something Oxford's supporting, so I'm just doing it when I'm not working on it. No, I almost got two Singapore students, but didn't quite work out. But maybe next time I'll get a student in Singapore. Yeah, so that's one reason. No. So I very much, in the instructionist spirit, basically gave the students complete free rein, but I demonstrated, a few different scratch variants and the Toon Talk, and also the pocket code that I showed you last night, this web-based, phone-based, Android-based way of making nice little apps. So long-distance birds were a really cute thing. The web lab, both projects, the playground used it where kids could collaborate even between London and Stockholm, where they could make something, give it to a bird, and it just appears on the nest in the Toon Talk in the other country. I showed you, if you hover over a robot, it gives you all this text explaining what it does, but it's really not very easy to read. The one thing that I think at some point would be great, or find if I got a student who would do this, would be given a robot, generate a little comic book of what the robot does. You can see at a glance all the things he does, and instead of just having to always watch him in real time, you could kind of read it more. And then the interface of the web version retains some of the nice things from the desktop, but it also has too many kind of non-game-like ways of doing things over buttons and so on, rather than in the desktop one, which is much more playful and so on. And this, I think, is the last slide. Unwatched robots, you can see, they seem to be running really fast. That thing got really wide really fast, or the numbers tripled. But it's still very, very much slower than if it was just pure JavaScript or something. So then there's all sorts of fun directions to possibly go. So Google Drive Real-Time, Google's got an API that gives you much of the same kind of support that they themselves use in Google Docs when multiple people are editing the same document. I've never done it, but you can see little cursors for where they are, and as people edit, everybody sees the latest version. So kids could be on the same floor, the same page, creating things on different devices, but all cooperatively building the same thing. And then there's this technology called WebRTC that would be good for the long-distance birds. I put in some support for speech. Maybe it's this playful spirit. Let's see if this will work anyways. There it is. So there was this 5-year-old that I was babysitting for about a month ago. And one of the first things he even asked me was, what's after octillion or something? He was really interested in really big numbers. So I said, I think it's nontillion. And he was asking me all these things about numbers. So I made this demo for him where it's just multiplying by 1,000 over and over again, except that it also sends it off to the speech engine, and it comes back with the textual equivalent. And there's She just said 1,000. So his mom thought this was really, the 5-year-old really thought this was great. And if we stop watching it for a second,
1 million, 1 billion, 1 trillion, 1 quadrillion, 1 quintillion, 1 sextillion, 1 septillion.
anyways, you could go for a long time like this or something, and all the words are spread out over it. So anyways, just forgot why I wanted to show that. Oh, just that that was one of a recent thing that I saw, that there was, the browsers have all this speech output, but they also have speech input, which I haven't touched yet, but that'd be another way in which you could improve the system and make it more playful and more easier to use. I even have ideas about how people could contribute programs that are living in the same space but still maintain some kind of security kind of concepts, but that would be a distant future where somebody's maybe going to really implement a bank account to talk rather than just demonstrate the ideas or something. And then browsers now have good support for 3D and making things much more like that. And that would be a great thing to add to it. And then if somebody wanted to go, after they build something in Toontalk, see it as JavaScript, that's possible. But, and then, going further. Thanks for coming. So that's, I guess, it. Again, these are all the, that's how you could see all these slides again with the links to all these things. Yeah, I think. Yeah, no, I'm trying to find, I don't quite understand how to attract open source developers to a project like this, other than writing papers about it and building it up and hoping somebody learns about it. One of the things I did do was, besides putting it all on GitHub from the start, was that I just, there's millions of frameworks on top of JavaScript, and there's all sorts of more nicer looking languages that compile to JavaScript and stuff. But I thought, to get the widest possible potential community behind it of developers, that I should just use pure JavaScript and use jQuery, but none of these frameworks, none of these coffee scripts or other languages on top of it, just so that somebody coming to it doesn't have to also learn a whole new layer on top of it. You just have to know JavaScript. And I also did was, but this is sort of standard practice these days, which is the whole look and feel of Toontalk here is completely controlled by a CSS file. Thanks for that. So that a graphic designer who doesn't know how to do any programming could say, oh, I think there's a much better layout here, and I think the fonts could be different, and the colors could be different. Or even, they could even replace any of the images with other images. They don't like the way that nest looks. So that somebody could change the whole, customize the look and the layout and the colors and the fonts without having to touch any programming. They just have to know CSS, and they just change the CSS file. And one of the things that I think is needed is separate CSS files, or a CSS file that adapts better to different kinds of screens. That on a small phone, you really don't want the same kind of layout of where things are on the same scale of things. So with the phone, it's not the optimal layout. It's good enough because the phone will shrink it and you can still zoom into parts and stuff. But for example, the buttons, the green flag and the red stop sign, on the phone they're much harder to touch because your finger's bigger and they're smaller. And, all those things need to be kind of customized for different kinds of processes.
How how hard would it be to translate this?
Ah, oh, good. Watch this. Thank you for asking. So, let me go to GitHub, because I forget. So here's the site, and here's this, and look at this. So, so you'll have to tell me how good this is, but so there it is. But I thought that they just have one Portuguese or something. So and notice even the text here changed, and if I hover over this, you know, the help is changed and so on. And even that program that was saying, you know, 1,000, 1 million, and the change and so on. Though it may.
Because this is Java doing
No, this is Google Translate doing it. But right.
No,
And
because it's getting into your Java program, right? It's
what?
in there, or
No, Java's not involved anymore at all. No.
this is the last.
Oh, that's funny. This gets translated. This used to get translated. Oh, the help's getting translated. Well, I have to track that down. But most everything's getting translated. Yeah, the Behavior Composer uses Google Translate as well to change the whole interface, and the way Google's done it, there's a really interesting idea, which is if you see something that's a really bad translation. Let's see, I think this works. There it is. I could say contribute a better one, and I could click on this, and then I could say, hey, there's a much better way to do this. And it doesn't change it for anybody, but I get a notification saying, do I want to accept this translation, this better translation for my website? And then from then on, anything that's at toontalk.github.io will use that contributed improvement to the translation. So you could even crowdsource improvements to the translation. So, but it used to be that Google Translate was kind of useful but really poor, but it's getting better and better all the time. So, I don't know, you guys could judge how good these, actually, but just going to try to find something that was, so here's like a really long text that's all generated. I don't know how good this is at all, but
Actually, you can correct it and relate it to the two talks.
yeah,
And then they don't want to.
yeah, that's right. Yeah. Right. Yep.
So the community could improve this.
Yeah, that's right. Yeah. But when I was just looking just now, I was a bit surprised because with the desktop version, in those days, we had different publishers that would actually do the translation of these Java, C++ tables. Anyways, there was an insistence that it be done all over again, because the Portuguese was so different than the Brazilian one. But here, Google didn't give you the translation.
Yeah, and the Portuguese too.
Oh, there was? I didn't notice that. So this is, it was, I don't see it as on the list. Don't see it. But maybe they'll do that, at some point. Well, they don't even do it for English either, UK, US or something. Funny.
Anything else?
No, other than, again, if anybody does want to help,
Search,
yeah,
always, every time you present, there is something else.
yeah.
And, the fact that when you
And part-time, yeah. But the whole HTML5 JavaScript world is really surprisingly, rich and powerful. There's just so much stuff out there, and it wouldn't be hard to connect to any either new APIs or new, external services or something, like I did do for the Google Drive.